Hello, welcome back. In this section, we're going to be looking at measures of the location of the data in section 2.3. So we're going to be finding the median, the percentiles, quartiles, and then calculating what something is called the 5-number summary. So to do this first one, we look at what's called the median. The median is something we've studied in other classes before. It's the number right in the center of our data. And you can think of the median as the middle value. And if it's between two numbers, remember we average those two numbers. So the median is also called the second quartile, also the 50th percentile, because it's just right smack dab right in the middle. Other locations are called quartiles or percentiles. Percentiles are split up into 100s or 100ths, and 90th percentile of an exam does not mean necessarily that you receive 90% on the test. 90th percentile means 90% of the test scores were the same or lower than you, and 10% of the test scores were greater than your score. So to calculate percentiles, the data must be in order from smallest to largest. Quartiles are the same as percentiles, but it's just a different way to name them. So the first quartile, that's the 25th percentile. It's the middle value of the lower half of the data. So split the data right in half. Look at the lower half, the middle of that. That's the 25th percent, or quartile 1. And the quartile 3 is the middle part of the upper half of the data. That's the 75th percentile, quartile 3. And quartiles, once again, may or may not be part of the data. Sometimes you take, if it's between 2 points, you have to take the two and average them. And once again, we need our data ordered from smallest to largest. And we have a formula here for finding a percentile. We're going to come back to this formula in just a moment. So here we have an example of the Academy Award winners of Best Actors in order of their age from smallest to largest. So if we want to find the 70th percentile, what we're going to do, well, I also show how to do this on Google Sheets, which is really slick. That's on that other video. So please check that one out. But to do it by hand for a small data set, it's going to be very easy to do. So we're going to use this formula right here. And on here, we're going to be finding the kth percentile. For our problem, we're going to find the 70th percentile. So k will be 70. So I could even replace that. N is the number of data items we have, and our data set is 29. So that will be 29 here. And that will give me my I value. And if I is an integer, then the kth percentile of the data value is in the ith position. So if it's 1, it would be in the first position. And if I is not an integer, then we round up or down to the nearest closest integer. So I'm going to take this to my calculator, which I tend to just use Google for my calculator for these easy calculations. So what was it, 70 divided by 100? And then that was multiplied by, we go back, it said n plus 1. And our n, remember, n is the number of data points, 29. So we take 29 plus 1 and 21. So that means the 70th percentile person is in spot 21. So we take this and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 18, 19, 20, 21. There we go, 21. So that's our 70th percentile. That makes sense. 30% is above it. 70% is below it. And we have 1, 2, 3, 4, 5, 6, 7, 8 above it. That makes sense too, because we have a total of 29. So that answer is 64. And the 83rd percentile, same work. We go back to that calculation, but this time we're looking for the 83rd, 24.9. So we take this number and we round it either down or up. That's 24.9, so that would be rounded up to 25. So we find the 25th number. And I know 25 that number 25 should have 4 numbers above it, the 26, 27, 28, and 29 spot. So I can count back this way. So there we go, 72. How we calculate percentiles by hand. It's much faster using Google Sheets for larger data sets. That's what we'll be doing. Okay. All right, so if we have a frequency graph like this, you could write out all of those, and it's a little more cumbersome and longer. Like there would be 4 2s and 5 5s and 14 8s. It takes a while to write all that out, but the calculation is exactly the same. All right, so when interpreting a percentile, we'll talk a little bit about what that means. So here's an example for us. On a timed math test, the first quartile for a time it took to finish the exam was 35 minutes. Interpret what that first quartile means. So if the first quartile was 35 minutes, that means 25%. At the 25% mark, percentile, students were at 35 minutes, or sorry, at the 35-minute mark, 25% of the students had turned in their test. So that means, there we go, 25% of the students finished the exam in 35 minutes or less, but then 75% took longer than 35 minutes. So a low percentile could be considered good. If you're thinking about a timed test, if you take too long, you might not be able to finish. Depends on the context of the problem. 100-meter dash, the third quartile for times for finishing in the race was 11.5 seconds. Interpret what this means. So third quartile for times, so third quartile, 75%. That means 75% of the runners finished in 11.5 seconds or less. So that's a way to think about it. A quarter of the runners took longer than 11.5 seconds. The next part is going to be more useful for our next section, but we can just talk about the interquartile range. That's just the difference from the 75th percent, or the quartile 3, to the 25th percent, quartile 1, and we just subtract those two numbers. This is called our interquartile range, and it's that middle 50% of our values. And this calculation here for a potential outlier is something we're going to be talking about in the future as well. So next section, we're going to be making some box plots, and I'll make a different video for that. All right.